Okay, so the objectives for this lesson are to draw a linear model through 2 points, write the equation of the linear model, and then make predictions using the equation of that model. You should be fairly used to doing scattergrams, and this is just building on what we've been doing so far with the scattergrams. Okay, so suppose we're given this example where we're given the average price of gas per gallon of gasoline for various years. So we started in 1960, it was 33 cents a gallon. Those were the days, huh? And then 1970 were 39 cents a gallon, and so on. Okay, and what we're going to do is we're going to, in part A, create a scattergram where T is the number of years since 1960 and P is the average price per gallon. Okay, so again, this is something you should be fairly familiar with. So if we just talk real quick here, if you go across the bottom axis, the year since 1960, okay, if we start at 0 and then for every tick mark being 5, so skip 1, say 10, skip 1, say 20, and so on. And then up the side, for gallon, for P, okay, this one, we notice we have to fit from 33 cents or $0.33 all the way up to 2.85 or $2.85. Okay, so that's one where if you use a scale of 20 or 30 cents, so 0.2 or 0.3, that should work out pretty well. Now the one that I'm going to use is just 30 cents. First tick mark will be 0.3, and then the second tick mark will be 0.60, and so on. For the sake of time, I'm going to allow you to finish that, so I would say pause the video and then pick up where you left off, and I'm going to switch this out into a scattergram that I already have completed. Okay, so here's the scattergram that I have completed. Okay, make sure you label it's 1960 and then the average price going up the side. And again, I use a scale of 30 cents per tick mark. Okay, so the next thing we look at in part B is draw a linear model through 2 actual points on the scattergram. Okay, now we're specifically going to use or choose 2 points in the scattergram. Okay, now this is not a great scattergram because the points are fairly spread out. Okay, so remember, when you draw a linear model, you want it to be close to all the points. Unfortunately, this one is tough to do. You can see that if I draw through the last 2 points, okay, that's a pretty bad linear model. If I draw through the first 2 points, okay, or maybe even the first and last point, that's not a terrible linear model, but you see all the other points are below it. Okay, here, here, and here. Okay, so what I'm going to do, this is kind of arbitrary, but what I think one of the better linear models for this would be is through the second point in year 10, so 1970, and then 30 years since 1960, so in 1990. Okay, so I'm going to draw the model through those 2 points. Okay, and of course I missed it just a little bit. Okay, we're going to imagine we went through that point right there. Okay, and then this point right here. Okay, so this point and this point are the 2 points that I'm using. So I'll make a note of that in the next part here. So we drew the scattergram, and then in part C, slope or the rate of change of your linear model. Okay, so M is our symbol or our variable for slope, M equals. Okay, now remember, that's y2 minus y1 over x2 minus x1. Okay, that's our formula for slope. Now the 2 points that I'm going to use will be the year 1970, which was a t-value of 10, 39, and that was the actual value from the, okay, so up here. Okay, it was that actual value. And then I'm also going to use when t was 30 in the year 1990, I'm going to use that point. So I'm going to use 30, comma 1.28. Okay, so those are the 2 points I'm going to use because that's what I chose to draw my model through. Okay, and now when we use the slope formula, the y2 minus y1, or the output minus the output, that'll be slope equals 1.28 minus 0.39 divided by minus 10. Okay, which will give us approximately 0.89 divided by 20. Okay, so what that's basically telling us is that in those 20 years, so from 1970 to 19, price of gas per gallon went up by 89 cents, or $0.89. Now, if we actually do that division, we end up with 0.0445. Okay, so when we do that division, what we're basically doing is making it a unit conversion, which is basically saying, when we look at our units now, $0.0445 per 4.45 cents, okay, or 4.5 cents approximately. Okay, so that was the average rate at which gasoline increased according on our linear model. Okay, so line is $0.0445 per year. The gas went up, the average price went up 89 cents in those 20 years, or at an average rate of 4.5 cents. I'm sorry, 4.5, or $0.0445 per year. Okay, so moving along to find the vertical intercept of your linear model. Now we can estimate, it looks like it's fairly close to 0. Okay, and again, I missed that point there just a little bit when I drew it. Okay, so that might be tilted down just a little bit more. Okay, but instead of just guessing what that p-intercept is, I'm going to use the points that we had in part C, and we're going to find the p-intercept using one of those points. Okay, so the idea here is we have a linear model, and that tells us we have something in y equals mx plus b form. Okay, so when you see linear, we should be thinking mx plus b. Well, instead of y, we have p for the price, and then instead of x, we have t. We know m, the slope, is 0.0445 because we just found it in the previous example. So our linear model off as p equals mx plus b. Well, we know that m is 0.0445. T, we're not exactly sure of yet. I should say that's changing. And then plus b, the y-intercept is what we don't know. In this case, the p-intercept is. Okay, so you can look at this as y equals mx plus b. Okay, we just changed the x variable to t because we have t comma p. Okay, so instead of y equals mx plus b, 0.0445 t plus b. Okay, so now this is where we look at our equation, and the whole idea here is that this line passes through those 2 points. So what that means is the equation of our line should work with either of those points, or both of those points. So I'm going to take one of those points. I'm going to take 10, 0.39 for a t and a p value, and we know that the line that we're trying to write, p value, 10 and 0.39, should work in this equation. So p, when that's 0.39, know that we have 0.0445 times t, which is 10, plus e, which is the y-intercept, which is what we're trying to find. Okay, and we're guessing it's going to be somewhere around 0. Okay, so we do that arithmetic, and we have 0.39 equals 0.445 plus b. Okay, and when we solve that by subtracting 0.445 from each side, we end up with the y-intercept, or the p-intercept, the b value being approximately negative 0.005. I'm sorry, I just said that wrong. Let me do that. B is approximately negative 0.055. Okay, sorry about that. Okay, so that is the p-intercept. Okay, so 0 comma negative 0.055. So the equation of our model, instead of y equals mx plus b, we're going to have p equals the 0.445. Okay, because the slope is always the same on this line, no matter what 2 points drew the line. That slope will always be the same for that line. And then the time since, or the number of years since 1960, that'll change. And then minus 0.055. Okay, so that's of our linear model. Okay, we're going to use that equation now in the second part to predict the average price of gas in 2015. Well, 2015, we had to think about what t value is that. Okay, well that's a t value of 55. So what we'll do, so in 2015, the average price is 0.0445 times 55, because we know t is 55 now, minus 0.055. Okay, and when you do that arithmetic, you end up with P is approximately $2.39. Okay, so the average price of gas in 2015 you would predict to be $2.39 or $2.39. Okay, the last part, F, we're going to use our equation to find the year, I should say predict the year, in which the price was predicted to be $2 per gallon. Well, $2 per gallon, that is a p-value in our equation. Okay, so the equation of our linear model, again, was p equals 0.0445 t minus 0.055. Okay, that's the general equation for our linear model. Now we know that p is $2 per gallon. So we're going to say 2.00 equals 0.0445 t minus 0.055. Okay, by adding 0.055 to each side, so we'll get 2.055 equals